Welcome to third part of lecture number 2 of engineering drawing and graphics for engineers. So in first two part, in part A and part B, we have generally introduced the scale, different types of scales, and then in second part of lecture number 2 we have discussed the plane scale, that how you will construct a plain graphical scale in your drawing. Okay, now in this third part of lecture number 2 we will discuss the construction of diagonal scale. See, we have different types of scale, for example engineer scale, graphical scale and representative fraction. So already we have discussed that with respect to time, when the drawing is shrink, then there will be error if you are expressing the scale in the form of engineer scale or representative fraction. But the graphical scale will we can say that if there is shrink occur in the map or plane, then shrinkage will be also occur in the graphical scale, so then there will be no error in the conversion of drawing dimension into actual dimension. So this is most important, that being an engineer, whenever you are drawing a structure or any plane or map, so you will have to express the scale. So the better form of the expression or representation of scale is the graphical form. Then we have different types of the graphical scale, like plane scale, diagonal scale. So the plane scale was discussed in the second part of this lecture, and now we will discuss the diagonal scale. So see, let's revise the plane scale. So in the whenever we are constructing a plane scale, so we have two units, for example meter and centimeter. Okay, or suppose we have centimeter and millimeter, or for example we have feet and inches. Mean we can measure up to 2 units. And in diagonal scale, that is used for very minute distances such as 0.1 millimeter, etc. Or through diagonal scale we can measure up to 3 units. Okay, remember the difference between the plane scale and diagonal scale. So with the help of plane scale we can measure up to 2 units, and with the help of diagonal scale we can measure up to 3 units, for example decimeter, centimeter and millimeter, or yard, foot and inches. Mean in one scale we can measure up to 3 units. Okay, either of SI system or FPS system. So small division of a short line are obtained by principle of diagonal divisions. Okay, we have some principle through which we can divide a short line into different parts. So principle of diagonal scale is to obtain division of a given short line AB in multiple of 10. For example, if we have a line, if we have a short line, for example AB line, so we are actually graphically dividing this line into 10 equal parts. Okay, so for example if we have 1 centimeter line, then this one portion will be equal to 0.1 centimeter. Okay, these two portion will be equal to 0.2 centimeter. Okay, the 3 portions will be equal to 0.3 centimeter, and so on. So that is called the principle of diagonal scale, that actually we have to divide a short line in multiples of 1 over 10, like 0.1 AB, 0.2 AB, 0.3 AB and so on. Okay, so for that purposes first you have to know about the graphical division of a line. That for example if you have a short line, for example if you have AB line, suppose that is 1 centimeter or 2 centimeter, or for example that is 1 inches. So how it will be divided into multiple of 1 over 10, how it will be divided into, how you will take its subdivision, for example 0.1 time of AB, 0.2 time, 0.3 time, 0.4 time. That is the principle of diagonal scale. So remember, first you will have to know about the graphical division of a short line, that how it will be divided into a multiple of 1 over 10. So see, for example, if you have AB line and you want to find out the 1/10th multiple of this AB line. So see, at one end of B, just draw a perpendicular line. Okay, AB is the given line and we are interested to find out the multiple, the 1/10 multiple of this AB line. So the procedure is that just draw a line perpendicular to AB at one end of any distance. You can draw it of any distance. Suppose that is point C. Okay, now just take a divider and of any length. Okay, take a divider and of any length divide this BC line into 10 equal parts. Remember, we have to divide, we have to find out the 1/10 multiple of this AB line. So the procedure is that at point B, draw a perpendicular line of any length. Okay, then with the help of divider, divide this BC line into 10 equal part. Again, that will be of any length. Okay, then join point C with A. Join point C with A. Okay, then draw parallel line, mean through 1, 2, 3, 4, 5 and so on. Draw parallel line to AB. For example, this is 1, 1 dash parallel to AB, 2, 2 dash parallel to AB, 3, 3 dash parallel to AB, 4, 4 dash parallel to AB, 5, 5 dash parallel to AB and so on. Okay, just draw the parallel lines to AB. Okay, now remember this 1, 1 dash, the length of 1, 1 dash will be equal to 10 time of AB. Okay, that will be 10th time 1/10th time of AB. For example, we have 5, 5 dash. Suppose this distance 5, 5 dash, that will be half of the AB. Okay, similarly 6, 6 dash, that will be 0.6 time of AB. So you can see that we have find out the multiple, the 1/10 multiple of this AB line. This is 0.1 AB, 0.2 AB, 0.3 AB, 0.4 AB, 0.5 AB, 0.6 AB, 0.7 AB, 0.8 AB, 0.9 AB and AB. Okay, so these are the 1/10th multiple of AB. This is called the principle of diagonal scale. Thus, each horizontal line below AB become progressively shorter than by 1/10th AB. Suppose that is AB. Okay, that is the given AB line. So the 9, 9 dash will be 1/10th time less than AB. Similarly, 8, 8 dash will be 1/10th time less than 9, 9 dash. And progressively the length of each parallel line is reducing by 1/10th of AB. So these are the 1/10th multiple of the given AB line. Okay. Now let's solve different problems of the diagonal scale, that how you will construct a diagonal scale. So the examples or the problems are taken from the engineering drawing book by Andy Butt, 53rd edition. Okay, so the first question is construct a diagonal scale of 3:200 showing meter, decimeter and centimeter. See, we have to represent 3 units. Okay, and to measure up to 6 meters. So the procedure is similar like that of the plane scale, that first you have to find out the length of the scale, then you have to draw the required line, then you have to divide it into the given parts. Okay, so see, first find out the length of the scale. So length of the scale will be equal to the representative fraction multiplied by the maximum length which you want to measure. And see, there are 100 centimeter in 1 meter, just to find out the convenient length. So meter will be cancelled with meter, and 6 multiplied by 100, that will be 600 divided by 300. So they in you will just get the we can say that, sorry, here we have 3. Okay, it is 3 by 300. So here you will get what, 9 centimeter. sorry, that is 3 by 200, so you will get, sorry, you will get 9 centimeter. Okay, so now the procedure is just draw a line of 9 centimeter. Okay, draw a line of 9 centimeter and divide this line into 6 equal part. Okay, so suppose that is 9 centimeter, so divide this line into 6 equal part. 1 2 3 4 5 and 6. Okay, I'm just drawing it by rough, so there may be some error. So just draw a line of 9 centimeter and divide it into 6 equal part, and to the first part just write here 0 1 2 3 4 5. Okay, so 5 centimeter is 5 meter will represented by this one, and 1 meter is represented by this portion. Okay, now see it, a, suppose that is AB line. Okay, that is AB line. Now divide the first part, divide this first part into 10 part. Remember, this one portion is representing 1 meter. Now when we divide this one part into 10 equal part, see 1 2 3 4 5 6 7 8 9 and 10. Okay, so now you can see that this one portion will represent what? 1 decimeter. Now through this scale up to here we can measure the decimeter in meter. Okay, now to represent the centimeter, so just here draw a perpendicular line up any length. Okay, and divide this line into 10 equal part. See, for example, 1 2 3 4 5 6 7 8 9 and 10. Okay, now just make this type of rectangle. Okay, draw these line. Okay, and draw the parallel line from these line which you have from these 10 parts, mean draw these parallel lines. Okay, these line will be parallel to each other. Okay, just draw these line parallel. I am just drawing it to a rough method, so there may be some error. And divide again, see this is OA, so it will be equal to this distance. Again divide it into 10 equal parts. 1 2 3 4 5 6 7 8 9 and 10. Now remember, join the first part from the top to this 0 point, mean join it with this 0, join the second part with the first one. Okay, join the third part with this 2, similarly fourth with this third, fifth point with this 4, mean alternatively join it with this line, and these line will be parallel when you draw it through some we can say that drawing instrument. So then these line will be exactly parallel to each other, and the last point will be joined with the point number 9. Okay, so now you can see that here we have 0, this is 1 decimeter, 2 3 4 5 decimeter, 6 7 8 9 and 10 decimeter. Okay, now as we have discussed previously, you can see that here we have also 1 and 2 and so on. Okay, so this distance is 1 decimeter, this is 0.9 decimeter, this is 0.8 decimeter, 0.7 decimeter, 0.6 decimeter, 0.5, 0.4, 0.3, 0.2, 0.1. 0.1 decimeter mean 1 centimeter, 0.2 decimeter mean 2 centimeter, 0.3 decimeter mean 3 centimeter. Okay, so see the 1 decimeter is furtherly divided into 1/10 multiple, it means that it is furtherly divided into 10 centimeter. So this vertical portion will represent centimeter. Here you can write as decimeter, and here you can write it meter. Okay, and see, just represent here the representative fraction, which is equal to 3 by 200. So this is the given diagonal scale. Okay, for example, now if someone want to represent the length of 3.74, for example 3.74, so this 3 is meter, 7 is decimeter, 4 is centimeter. Okay, so you have to take start from this 3. See, 1 mean you have to take start from this 3. So 1, 2, 3, that is 3 meter. Now we have 3.7. So 3.1, 2, 3, 4, 5, 6, 7. Okay, so this is 3.7. Now we have to take 4, 3.74. So 3.7 is up to here. So 3.71, 3.72, 3.73, 3.74. Okay, so from here up to here, that is the distance of 3.74. Okay, so this is the diagonal scale. It will be more clear with the help of other examples. See, construct a diagonal scale of RF 1/4000 to show meter and long enough to measure up to 500 meter. So find out the length of the scale, which will be equal to 1/4000 multiplied by the maximum length, which is 500 meter. Okay, so just multiply it by 100, so it will be convert into centimeters. Zeros will be cancelled, 1 0 will be cancelled with this one, and 50 divided by 4, it will be equal to 12.5 centimeter. Okay, now just draw a line. Okay, just draw a line of 12.5 centimeter, divide it into 5 equal part, 1, 2, 3, 4 and 5. See, here we have 500 meter. So see, we have divided the 12.5 centimeter line into 5 parts. So each part will represent 100 meter, 100 meter, 200, 300, 400, and the 100 is to this side. So the total line is representing 500 meter distance. Okay, now you can divide the, because now we cannot divide it into 500 parts, because then the points will be too much less, and through which we cannot then transfer the dimension. So now divide the first part into 10 equal parts. See, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. See, you can see that this portion is of 100 meter. So this one part will represent 10 meter, 10 meter, 20 meter, 30 meter, 40 meter, that will be 50 meter, 60, 70, 80, 90 and 100. Okay, mean through this scale we can measure up to 500 meter distance. But if you have to measure 1 meter distance, what you will do? So we have to represent the up to the third subdivision of the meter. Okay, so this is 100 meter. Now this 100 meter distance, we have divided it into 10 parts. So this one portion is representing 10 meter. Now we have to divide this one portion furtherly into 10 parts. So each part will represent what? 1 meter. Okay, so just draw here a perpendicular, make this required rectangle and divide it into 10 parts. See, 1, just draw the parallel line, 1, 2, okay, 3, 4, 5, 6, 7, okay, 8, 9 and 10. Okay, mean that is divided into 10 parts. See, so this will represent 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Mean we have to divide this 10-meter distance into 10 parts. So then we can measure up to 500 meter from this scale. Okay, also take here the 10 equal division: 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now join this first point to the 0 point, join the second point into the first point, join the third point into the second. Mean alternatively just join these points. Okay, sorry, I am drawing it free-handedly, so the line is not exactly. When you draw it through some instrument, then it will be more accurate. Okay, so now see, this distance is 10 meter, this is 9 meter, 8 meter, 7 meter, 6 meter, 5 meter, 4 meter, 3 meter, 2 meter, 1 meter and 0 meter. Okay, so this is the required scale through which we can measure up to 3 units, mean 100 unit, 10 unit and multiple of 1 units. Okay, now for example, if you have to represent 3, 4, 5, you have to represent 3, 4, 5 meter. Okay, so just take from here, that is 100, 200, 300, 310, 20, 30, 40, okay, 41, 42, 43, 44, 45. So from this point up to here, that will be equal to 345 meter. Okay, now just draw a diagonal scale of 1:2.5 showing centimeter, millimeter and long enough to measure up to 20 centimeter. So just find out the length of the scale, that will be 1/2.5 multiplied by 20, so you will get 8 centimeter. Okay, now just draw a line of 8 centimeter and for example divide it into 4 equal part: 1, 2, 3 and 4. Means see, this 8 centimeter distance can measure, can transfer the drawing dimension into actual dimension of 20 centimeter. Mean if in the drawing you have 8 centimeter distance, in reality it will be equal to 20 centimeter. So see, this one line, this one portion is representing how much? 5 centimeter. Okay, this one point is representing 5 centimeter. Now divide it into 5 equal part: 1, 2, 3, 4. Mean this one portion on the drawing will represent 1 centimeter of actual dimension. Okay, now furtherly, if you have to divide it, if you have to take the dimensions up to the millimeter, so then just draw a perpendicular line at this point, okay, and divide it into 10 equal part. For example, suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so see, then just draw these parallel line, okay, up to here. 1, 2, 3, 4, this is 5, 6, 7, 8, 9 and 10. And also divide this portion into 5 equal part. Now join the first point with this 0 point, join this one with second, this one here, it here. Now you can see this was 1 centimeter distance. Yeah, here it is 1 centimeter distance. So this will be 0.1 centimeter, 0.9 centimeter, 0.8 centimeter, 0.7 centimeter, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1 centimeter. 0.1 centimeter mean 1 millimeter. Okay, so through this we can measure up to millimeter. Clear? Now suppose if you have to represent a distance of we can say that suppose if you have to represent a distance of 8.3 centimeter, 8.3 centimeter mean actually these are centimeter and these are millimeter. 0.3 centimeter mean 3 millimeter. Okay, so just take from here, see that is 5 centimeter, 6, 7, 8. This distance is representing 8 centimeter, 8.1, 8.2, 8.3. So if you have this much distance on the drawing, in reality it will be equal to 8.3 centimeter. Okay. Second, construct a diagonal scale of representative fraction 1/32 showing yard, feet and inches and to measure up to 4 yard. So just find out the length of the scale is equal to 1/32 multiplied by 4 yard. And remember, in 1 yard we have 3 feet, and in 1 feet we have 12 inches. So when you just solve it, you will get 4.5 inches. Okay, so just draw a line of 4.5 inches, divide it into 4 equal part. Each part will represent 1 yard. 0, 1, 2, 3, and 1 is to this side, so that is yard. Now divide the first part into 3 part, 1, 2 and 3. So this each portion will represent 1 feet because the 1 yard distance is divided into 3 part. So it will represent how much? This one portion will represent 1 feet. Now just draw here a perpendicular line of any length. Okay, and divide that perpendicular line into 12 equal part. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. Okay, and take here that 3 points. So just join it here, join this one here and join this one here. See, we have divided this 1 feet distance into 12 parts. So this each part is reducing by 1 inches. Okay, so it is 12. Okay, mean here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Mean this 1 feet is divided into 12 inches. So this will be, see here, that is 1 feet distance, mean that is 12 inches distance, that is 11 inches, that is 10 inches, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Okay, so now through this scale we can measure yard, feet and inches. Suppose now you have to represent 2 yard, 1 feet and 6 inch. Okay, so start here, 1 feet, 1 yard, 2 yard and 1 feet, 2 yard and 1 feet up to here, 2 yard, 1 feet, 1 inch, 2 inch, 3 inch, 4, 5 and 6. So from here up to here, if in the drawing you have this much distance, In reality it will be equal to 2 yard 1 feet and 6 inches. Okay, just draw a scale of showing 1 over 100 inches and to measure up to 5 inches. Okay, now see, we have just to find out the length of the scale, which is equal to 1 over 100 multiplied by 5 inches. Okay, 1 over 100 multiplied by 5 inches. So see, actually we have to draw a full size scale. It means that we have to measure up to the 100th part of an inch. 100th part of an inch. Okay, so just draw a line of 5 inches, divide it into 5 equal parts. So see, that is 0, 1, 2, 3 and 4. If we draw a 5-inch line and divide it into 5 parts, so each line will represent what? 1 inches. Now divide the first portion into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these each part is representing what? 0.1 inch, because this is 1 inch distance and we have divided it into 10 parts. So this will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1 inch. Draw here a perpendicular line, divide it into 10 parts. 2, 3, 4, 5, 6, 7, 8, 9 and that is 10. Okay, see, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Up to here we will have. Okay, just join these line vertically. Just draw it your vertical line and extend these line up to here. Now divide this portion again into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Join the first portion with the 0, second with 1, third with second, fourth with third, fifth with fourth, sixth with fifth and so on. Okay, means just join these lines and see, now we have this 0.1 inch distance and this 0.1 inch is furtherly divided into 10th part. So this will be 0.1, this will be 0.09, 0.09, 0.08, 0.07, 0.06, 0.05 and so on. Mean 0.1 inch is furtherly divided into 10 part. 0.1 inch is furtherly divided into 10 part. So here we have the inches, here we have the tenths, okay, and here we have the hundredths. So now if someone want to take 2.46 inch, 2.46 inch, so see 2.1234, 2.4, 1, 2, 3, 4, 5, 6. So from here up to here, this distance will be equal to 2.46 inches, and that will be, in drawing that will be also 2.46 and in reality that will be also 2.46. so this is a full size scale. Okay, remember here you have to represent the unit inches, tenths and hundredths. Okay, just go to the previous example. Here you have to represent yard, here we have feet, and here we have inches. Okay, and also you have to represent the representative fraction. Similarly, previous example, here we have the centimeter, this one is also centimeter, and this one is millimeter. Okay, previous one. we have the meter, that is also meter, and here we have also meter. Okay, so just remember the convention and standard representation of the scale, that you have to represent the higher unit to the right side, then the middle unit to the left side, and the lowest unit into the left top corner. Last problem, the area of a field is 500 square meter, that is the actual area. The length and the breadth of the field on the map is 10 centimeter and 8 centimeter. Construct a diagonal scale which can read up to meter, which can read up to 1 meter. Okay, mark the length, and you have to mark this much length. What is the representative fraction? Now see, the real dimension of the field is 50,000 square meter. Okay, and suppose you have drawn it 10 by 8 centimeter. Now this is the drawing dimension. In reality it is 500 square meter. So see, what will be the drawing area? What will be the drawing area? So 10 multiplied by 8, that will be 80 square centimeter. Okay, now the scale is 80 centimeter square of the drawing is equal to 50,000 square meter in reality. I mean, this is the drawing dimension, this is the actual dimension. So it means that just divide both sides by 80. Okay, so it means that 1 square centimeter in the drawing is representing 625 square meter in the actual. 1 square centimeter, mean in the drawing, if you have 1 square centimeter area, in reality, yeah, in the ground it will be 625 square meter. Yeah, just take square root on both sides. So 1 centimeter on the drawing will be equal to 25 meter in reality. Okay, so see, now the representative fraction will be equal to 1 centimeter divide by 25 meter. Okay, 1 centimeter divide by 25 meter, yeah, multiplied by in 1 meter we have, in 1 meter we have the 100 centimeter. Okay, just find out the representative fraction. So it will be 1 over 2500. Now that is the representative fraction, and that was also the requirement of the question that determined the representative fraction. So that is 1 over 2500. Clear? Now find out the length of the scale. So length of the scale will be equal to the representative fraction. Okay, representative fraction 1 over 2500 and multiplied by what is the total area. So totally we have to measure 500 and 200. Mean in reality it will be this one, 500 and 200, it is 50,000 square meter. We have to measure up to this much area from the scale. So you will have to construct such a scale which is able to measure up to 500 meter. Just multiply it by 100, so it will be centimeter, and from this you will get 20 centimeter. Now that is the length of the scale. That is the length of the scale. Remember this value. Let me clear it. So just draw a line of 20 centimeter. Okay, just draw a line of 20 centimeter and divide it into 5 equal part. 1, 2, 3, 4 and 5. So 0. Now see, each part will measure up to 100 meter, because when we were determining the length of the scale, so we have multiplied the representative fraction with the maximum length which we want to measure. So the maximum length which we want to measure is 500 meter. Up to 500 meter we have to convert the dimension. Okay, so this one portion will represent 100 meter. Okay, now just divide the first portion into 10 part. 1 2 3 4 5 6 7 8 9 and 10. So this one portion will represent 10 meter. Okay, draw here a vertical line, divide it into 10 equal part. 1 2 3 4 5 6 7 8 9 and 10. Okay, see, the 100 meter portion is divided into 10 parts, so it will represent 10 meter. Now this 10 meter distance is furtherly divided into, we can say that, 10 parts. So each part is progressively reduced by 1/10. Okay, so just take here 10 division and join the first with the 0, second with first, third with second, fourth with third, fifth with fourth, and so on. So this 10 meter distance is furtherly divided into 10 part. Okay, so now if you have to represent the 235 meter distance, so see, that is the 200 point. So this is 100, 200, 210, 220, 230, 240, sorry, 230, 231, 232, 233, 235. So from this point up to here, it will be a distance of 235 meter. Mean, if in the drawing, if you have this much distance, in reality it will be equal to 235 meter. Okay, just write here the unit, because to the left side from 0 and to the right side from 0 the units are same, so just write it at the center. It is meter. Okay, this one is also meter. Just mark here 1 2 3 4 5 6 7 8 9 10. Okay, and just write here the representative fraction, that is 1/, which we have determined in the that is 1/2500. Okay, and just join these line parallelly to the last line. Okay, so that is the required diagonal scale. Okay, now see, if you are interested just to divide a line to measure the dimension in 1/100th of an inch. So for example, if you have this 1 inch distance, so divide it into 10 equal parts. Mean this 1 inch distance divide into 10 equal part, draw a vertical line and divide it into 10 parts. Okay, now join the first point into 0, second into 1, third into 2, and draw these parallel line. So see, you have, that was 1 inch distance, we have divided it into 10 part. So this one portion is 0.1 inch. Now you can see that this is also 0.1 inch. Now that is furtherly divided into 10 part. So this is 0.1 inch, this is 0.09, 0.08, 0.07, 0.06, 0.05, 0.04, 0.03, 0.02, 0.01, 0.01. Mean this is the 100th part of an inch. Okay, see, now this is the, from here to here, this is 0.37. see, 0.1, 0.2, 0.3, 0.31, 0.32, 0.34, 0.35, 0.36, 0.37. Okay, and that is the diagonal scale which we have also drawn in the previous slides. If you draw it through actual dimensions and actual with the help of the drawing instrument, so the diagonal scale will be look like this one. Okay, now this is, see, 1.37. so up to here that is 1 inch, 1.1, 1.2, 1. that is 1 inch, 1.1, 1.2, 1.3. Then in this line go 1.31, 1.32, 1.33, 1.34, 1.35, 1.36, 1.37. okay. Similarly, suppose if you have to divide an inch into 1/64th part, so just this is 1 inch distance, divide it into 8 part, so this one portion will be 1/8. Now this one portion is furtherly divided into 8 part, so this one portion is 1/64th part of an inch, 1/64th part of an inch. okay. Similarly, this is 1/28th part of inch. If you have an inch distance, divide it into 8 part, so this will be 1/8. This will be 1/8. Now this 1/8th part is divided into 12th part, so here this portion is representing 1/128th part of an inch. okay, so this is actually the basic principle of the diagonal scale. So thank you. This was all about the scales. So in this lecture number 2, we have discussed the scales, types of scale, plane scale and diagonal scale. If you have any question or comment, you can ask. Thank you.